Hi, how is it going? Welcome to Code with Z. In today's video, we gotta reverse this part of our linked list here. Why? Well, because that's what LeetCode 92 reverse linked list part 2 is asking us to do. As you can see, it says, given the head of a singly linked list and two integers, left and right, where left is smaller or equal to right, reverse the nodes of the list from position left to position right. So basically, this part, we have to reverse this part. And then at the end, we have to return the reversed list. Okay, let's see how you can solve this. So for example, our left is 2 and our right is 4. And this is going to be our linked list. And we have to reverse this part that we have here, meaning 4 has to come here and 3 has to stay here and 2 has to come here. So let's bring this down and let's visualize how you can solve this. I'm going to visualize everything so you can see how things work with your own eyes. But first of all, in these kind of problems, we usually need to have a dummy node that's going to save us from checking a lot of edge cases. So we're going to define a dummy node and we're going to fuse this to our head like so. As you can see, we put this here. So now our dummy node is pointing to this node. And then we're going to have a pointer. Typically in linked list questions, we usually have a pointer. This pointer is going to be called previous and it's going to be pointing to our dummy node in the beginning. We're going to make this pointer go through our linked list until we reach one node before our left. Well, let's do that. For example, now we're here, and if we check, we are one node before our left node. As you can see, one node before our left node, so we're gonna stop. Once we reach this position, we're gonna define two other pointers, and that's everything we need. The next one is gonna be called start, and it's gonna be basically symboled with S. And then we're going to have another one called then, and it's going to be symboled with T. And start is going to point to the node after our previous. So basically this node that we have here, the node that we have to start reversing from, and then is going to point to the node next to our start. Therefore, we have start and we have then. And this is everything we need. Once we have these set like this, we're going to follow 4 simple rules. The first one is that start should always point to the node after then. The second one is that then should point to what previous is currently pointing to. The next rule is going to be previous should now point to then. And the last one is that then should be updated to point to the next node for the next step. And you're going to see how all of this works in the visualization, don't worry. So let's start. The first rule is that start should point to the node after then. Well, this is start, this is then, and the node after this one is gonna be this 4 that we have here. So start should point to 4, like that. So instead of start pointing to 3, it should point to 4. Okay, 1 is done. Our then pointer should point to what previous is currently pointing to. Well, previous is pointing to start, or this node with the value of 2 inside of it. So this node has to point to here, like so. After that, we say previous should now point to then. So previous should point to then, like so. I know this is getting messy, but this is how we can actually solve this problem. It's going to be these 4 rules, and we're just going to keep on repeating them, and it's going to reverse our linked list. And the last one is that then should be updated to point to the next node for the next step. So you got to move then, like so. And basically, once we do that, we're going to repeat everything that we had, because this is going to be inside of a loop, and the same thing is going to keep on happening. We're going to say start should point to the node after then. Start, the node after then, so like so. Start is pointing to the node after then. Then should point to what previous is currently pointing to. Then should point to what previous is currently pointing to, which is 3, like so. And after that, previous should now point to then. Previous should now point to then, like so. And lastly, then should be updated to the next node. Well, let's do that. Simple as that. Now we're out of this area that we had to reverse. And if we check, we actually have this. We actually have D14325. We've actually reversed it. Why? Well, as you can see, 1 is pointing to 4. 1 is pointing to 4 and 4 is pointing to 3. As you can see, 4 is pointing to 3. And 3 should point to 2. And if we check, 3 is pointing to 2. And then 2 is pointing to 5. And if we check, 2 is indeed pointing to 5. So even though this is messy, this is actually the correct answer because we've actually reversed it, as you can see. So this is equal to what we have here. So now that we have this, we're going to return everything that we have after our dummy node. So basically everything that we have here, and that's going to be our answer. Now let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need to have is going to be our dummy node, and this is going to be basically a new list node like so. And we got this list node from the question itself, which basically defines a node for us. And then we're going to have dummy.next point to the head, and then we're going to define our previous pointer, and this is going to be pointing to dummy in the beginning. And then we have to move our previous until it reaches a position that's one node before our left. So just like we saw in the slide. So we're going to say for let I being equal to 1, and we want to keep on looping as long as I is smaller than left, and then I plus plus, and each time we're going to say previous is equal to previous dot next. Simple as that, because we want to keep on moving our previous one by one until we reach a position where it's one node before our left. That was given to us by the question. And once we reach that, we want to define our two other pointers. So the first one is going to be start, and this is going to be basically equal to previous dot next. After that, we're going to have then, and this is going to be basically equal to start dot next. Once we have these settled, we have to actually go through the loop and follow the 4 rules that we had. So we're going to say for let I being equal to 0, and we want to keep on looping as long as I is smaller than right minus left. And I'm going to explain this in a bit. Don't worry. Here, we have to write down the rules that we had. But the reason that we say right minus left is because we want to know for how long we want to keep this loop going. And for how long we want to keep this loop going is basically this part of our linked list. We only want to reverse this distance that we have here, and this distance is equal to right minus left. So here we say, let me scroll down, start dot next should point to then dot next, and then dot next itself should point to previous dot next. After that, previous dot next should point to then, and lastly we have to move our then pointer to the next node, if you remember, and we do that by saying then should point to start dot next. Simple as that. And then at the end, after we're done with this loop, we're gonna return dummy dot next, anything that comes after our dummy node. There's only one small thing that's left, and that's if we were given an empty linked list. If that was the case, if head did not exist, we want to return null. And that's going to be it. Let's run this and see if we can actually get accepted. Moment of truth. And let's see. Awesome. Let's see if we can actually pass all of the test cases. Moment of truth. Let's see. And we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.